Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of adventure. This time, Sue and I are diving into the really fast-moving world of AI, large language models, and GPTs.
That's right, Bob. And our mission today really is to get past all the hype. We
hmm
want to help you understand what's actually going on under the hood with these technologies.
Yeah, definitely want to demystify things. We'll look at what AI, LLMs, and GPT actually are, how they work.
And crucially, how they're shaking up something pretty fundamental, how we build software, apps, websites.
Absolutely, it's a big shift.
Yeah.
So, Sue, let's start right at the beginning. AI, artificial intelligence, we hear it all the time. What are we really talking about?
Well, at its core, Bob, AI is about computer systems designed to mimic tasks that normally need human intelligence. Things like learning from experience, making decisions, solving problems.
Okay, basic AI. But then there's this term generative AI, or GenAI. That feels like something new or different.
It is, yeah. That's a really key distinction. Gen AI is a type of AI built on machine learning, but its whole purpose is to create something new,
Create. Like what?
like generating text, creating images, writing music, even generating actual computer code, which is fascinating. It doesn't just analyze data, it produces novel content.
So it's not just sorting emails, it's writing them.
Kind of, yeah. Or writing a story, or designing a logo. And sometimes they show these surprising emergent capabilities doing things they weren't explicitly trained for. It hints at something. Well, more than just pattern matching.
Okay, intriguing. That brings us to LLMs then.
Mm-hmm.
Large language models. You hear that constantly.
Mm-hmm.
What makes them large? Is it just size?
Well, size is definitely part of it, Bob. We're talking models built with millions, often billions of parameters. Think of parameters as like connection points in a huge network.
Mm-hmm.
But large also refers to the absolutely massive data sets they're trained on. Just enormous amounts of text and data from the internet, books, code, everything.
So they learn language from basically the whole internet.
Pretty much. Yeah, huge chunks of it anyway. They learn grammar, context, facts, biases, the whole spectrum of human language. That scale lets them understand really subtle things about how words relate. They're often called foundation models for that reason.
Foundation models, meaning they can be built upon.
Exactly. You can take this general language understanding and then adapt it or fine-tune it for lots of different tasks without starting from scratch each time.
Right. So where does GPT fit in all this? Is GPT just another name for an LLM?
Good question. GPT, that's Generative Pre-trained Transformer, is a specific type or family of LLMs. It's the architecture developed by OpenAI.
Ah, okay. Like a specific brand or model.
Sort of, yeah. They're famous for their scale, like GPT-3 having 175 billion parameters, which
Yeah.
was huge at the time, and how good they are at generating text that sounds really human.
And that's down to the transformer part.
Yes, exactly. The transformer architecture is kind of the secret sauce. It uses a mechanism called self-attention.
Self-attention.
Yeah, it lets the model weigh the importance of different words in a sentence or even across long passages of text to really understand the context. It can figure out that a word used way back at the start of a paragraph is actually crucial to understanding something later on. It's very efficient at processing sequences.
Okay, that makes sense. So how do these things, these LLMs like GPT, actually learn? You said they're trained on massive data sets, but what does that process look like? It's not like sending them to school, right?
No, not quite school. It's generally a two-phase process, Bob. First, there's pre-training,
Pre-training.
right?
Yeah.
This is where the model just absorbs that massive amount of text data we talked about. Wikipedia, books, websites, code repositories, billions of words.
And it's just reading.
In a sense, it's unsupervised learning. It's figuring out statistical patterns, like which words tend to follow other words, grammar, context, relationships between concepts. It's building this huge internal representation of language.
Okay, so that's the general knowledge base. What's the second phase?
Yeah. That's fine-tuning. After it's got this broad understanding from pre-training, you can fine-tune it on a smaller, more specific data set to make it good at a particular task.
Like translation.
Yeah.
Or answering specific types of questions.
Exactly. Or, really importantly for our discussion today, generating computer code. And they can often learn these specific tasks surprisingly quickly, sometimes with just a few examples. That's called few-shot learning, or even just from a clear instruction, which is zero-shot prompting.
Wow. So you don't need massive specific data sets for every single task.
Not always, no. That foundation from pre-training does a lot of the heavy lifting. That self-attention mechanism helps it adapt quickly.
You're listening to OTO TV with research by author Paul Bulow.
And Bob, this brings us to something really exciting.
Yeah, this is where it feels like things get really practical, maybe revolutionary even. These AI, LLM, GPT tools, they've totally changed how code gets written, how apps and websites get built. It feels like a huge shift.
It absolutely is, Bob. It's a fundamental change. The really mind-blowing thing here is the realization that, honestly, almost anyone can now learn how to write prompts,
Mm,
instructions, basically,
right.
to get these tools to generate code. And often it's code you can actually deploy pretty quickly.
That's incredible. It makes coding suddenly feel accessible, like
Yeah.
truly accessible in a way it maybe never has been before.
Completely. It's lowering that barrier to entry massively.
Yeah.
People who never thought they could code can now start building things.
And there's a term for this, right? People are calling it vibe coding.
Yeah, vibe coding. It sounds fun, maybe a bit casual.
It does. Sounds easy, low cost,
Yeah.
powerful.
And it can be all those things. It genuinely is opening up coding to, well, potentially everyone. The idea that you can build something functional with tools accessible on just a phone or a regular computer,
Mm.
that's huge.
It really democratizes creation, doesn't it?
It does. But, and this is a really important but, Bob, we have to remember the technical realities.
Okay, the caveats.
Exactly. You still absolutely need proper planning. You need clear outlines for what you're building. You need some business sense about why you're building it.
Hmm.
And critically, you still need quality assurance, testing, revising the code. All those traditional steps of software development, they don't just disappear.
Right. So it's not magic. It's a powerful tool, an accelerator maybe, but not a replacement for the whole process.
Precisely. Think of it as augmentation. It speeds things up, makes new things possible, helps you get started, maybe handles boilerplate code. But the thinking, the planning, the testing, that human element is still crucial for anything serious.
That's a really important balance to strike. The potential is huge, but we need to be realistic about using it effectively and safely.
Absolutely. Which leads us naturally into thinking about the limitations, the challenges we need to keep front of mind.
Yeah, we've touched on the power, but what are the big watchouts, especially if we're talking about deploying code generated this way?
Well, probably the number one concern, Bob, is something called hallucination.
Hallucination, like the AI is dreaming.
Sort of. It's when the LLM generates output that sounds totally plausible, confident even, but it's actually incorrect, nonsensical, or just made up,
Yeah.
ungrounded in reality.
Ooh, okay. That sounds risky, especially for code.
It can be very risky. Imagine it generating code with subtle security flaws or logic errors that aren't immediately obvious. It happens because the model might be drawing on flawed patterns in its training data, or it might just misunderstand the prompt slightly. You can't just trust the output blindly.
Right. Verification is key. What else?
Another major one is bias, because these models learn from the internet, essentially.
They learn our biases too.
Exactly. They absorb the societal biases, racial, gender, cultural, all sorts, that are present in all that text data. And worse, they can sometimes even amplify those biases.
So the output could be skewed or even discriminatory.
Potentially, yes. If you ask it to generate, say, descriptions of people in certain professions, it might default to stereotypes reflected in the data. Mitigating this bias is a huge area of ongoing research, but it's a persistent challenge.
So we have hallucination, bias. These are significant hurdles for safe and fair use.
Definitely. And it means, for you listening, as these tools become more common,
Yeah, what's the takeaway for us?
it means critical thinking is more important than ever. These tools offer amazing speed, amazing creativity, especially in coding with this vibe coding idea.
Mm-hmm.
But you have to understand how they work, what their weaknesses are. You need to know when to trust them, when to question them, and when human judgment and careful testing are absolutely essential. Use the power, but use it responsibly.
That makes sense. Harness the efficiency, but don't switch off your brain.
Yeah.
Especially with vibe coding, it's exciting that it could bring coding to potentially billions more people.
Imagine that.
Right. People who maybe never would have gone through traditional programming training. What kinds of new ideas, what innovations might pop up when that barrier is lowered so dramatically?
That's the really exciting unknown, isn't it? A whole new wave of creators building things we haven't even conceived of yet. It's definitely a future worth watching closely.
Couldn't agree more, Sue. A fascinating and slightly daunting landscape ahead.